All right, we are going to do section 3.1, the quadratic forms notes. The SM2 just stands for secondary math 2. So this is section 3.1, quadratic form notes. There are 3 different types of quadratic forms that we're going to talk about. They're down here on the bottom of our page. There's the standard form, the factored form, and the vertex form. We'll get to those. First, we're going to talk about some vocabulary parts of a parabola. So you notice we have this graph of a parabola. The blue graph is a parabola. The blue part, that's the parabola. And there are some things that are labeled. A y-intercept, now this shouldn't be new. Y-intercept is a place where the graph crosses the y-axis. So a y-intercept is just a point where the graph crosses the y-axis. Now, how do we find them? How do we find a y-intercept? We just replace the x with 0. Because if you're going to be on the y-axis, see that y-intercept right there? There he is. You only get on the y-axis if you have an x value of 0. Points are on the y-axis if the x value is 0. So to find a y-intercept, we replace x with 0 in the equation. X-intercepts, they're going to be points where the graph crosses the x-axis, point or points. When you're talking about quadratic functions, there can either be 2 x-intercepts, 1 x-intercept, or no x-intercept. So x-intercepts are points where the graph of your quadratic crosses the x-axis. And think about it. These 2 points right here on our graph, look at the graph here. Those 2 points are the x-intercepts. They're going to happen when y equals 0. That's how you get on the x-axis. The y value has to be 0. So replace the y with 0 in your quadratic equation, in your quadratic function, and you've got your x-intercepts. Direction of opening. Okay, we have quadratics that open upward. The shape is called a parabola. We will also look at quadratics that open downward. So they'll either open up or they'll open down. How do we decide whether they open up or down? Well, it depends on the number a. If a is greater than 0, remember greater than 0 means positive. So if a is positive, it's going to open upward. If a is negative, meaning less than 0, if your a value is negative, it's going to open downward. The vertex, notice in this picture down here, the vertex is the point where, see if we follow it from left to right, it's going decreasing. At the turning point, it changes to increasing. So the vertex can be called the point where it changes from decreasing to increasing. When that parabola opens up, if it opens down, it switches from increasing to decreasing. We're just going to call it the turning point. Okay, it's the turning point. It changes direction from going down to going up, or from going up to going down. Decreasing to increasing, or increasing to decreasing. That turning point, the notation we often use for the vertex is h comma k. For now, we're going to use that. The axis of symmetry. Okay, looking at this graph again. The axis of symmetry, here it is. They drew a dashed line because it's just a reference. That axis of symmetry is a reflection line. If we take a point on one side of the axis of symmetry and we reflect it across, it will have a partner on the other side. So the axis of symmetry, notice it is a line. It is always a vertical line through the vertex. That's the axis of symmetry, a vertical line through the vertex. And it's a reflection line for the parabola. If you have a point on one side, you reflect it to the other side, you'll have another point on the other side. The symmetry line is x equals a constant. That's the equation of the line. So the vertical line through the vertex is going to be x equals h. Vertical lines have equations x equals a constant. Or what we will discover in an upcoming lesson is that axis of symmetry is also x equals negative b over 2a. We'll mention that right now. We'll come back to that in an upcoming lesson. Okay, now we're going to talk about how to change from one form to the other. Actually, we're going to go from standard form to factored form and from standard form to vertex form and talk about where it's easy to find some of these pieces of information. So from standard form, first of all, let's identify the y-intercept. To find the y-intercept, we replace the x with 0. So if we replace the x with 0, we have 0 plus 0. 0 squared is still 0. 4 times 0 is still 0. So we get y equals negative 5. So for this first example, our y-intercept is a point 0, negative 5. In other words, the graph of that quadratic would go through the y-axis at negative 5. We know this quadratic, the graph of this quadratic is going to open up because a is positive 1. Since a is positive, it's going to open up or upward. Okay, it's the direction of opening. We're just going to say it opens up. Now we're going to talk about how to get from the standard form to the factored form. And then we'll talk about how to get from the standard form to the vertex form. Now we can leave a 1 in there if we want. Doesn't matter. So we're going to start with standard form. We're going to put it in factored form. Now, do you notice the a is out in front? You have to divide out the a. In this case, a is 1, so there's really nothing to divide out. So we're just going to factor it. We're going to use our box method for factoring. All right, so remember how this goes. We do a times c. A is 1, c is negative 5. That product is negative 5. I now look for two numbers that have a product of negative 5, but they have a sum of 4. Remember, the b controls the sum. So if I do a positive 5 and a negative 1, that will have the correct sum, which is 4. Right, we're going to put the first term in the first square, last term in the last square, middle term gets split into a 5x and a negative 1x. And then we find the GCF for each row and each column. And then we'll have our factored form. So to find the factored form, we factor. So for this particular quadratic, our factored form is going to be y equals x plus 5. Oops, let me write it up a little bit higher. X plus 5 times x minus 1. So there's our factored form. Now, how do we find the x-intercepts from the factored form? Well, it's really easy. We just replace the y with a 0. Okay. And then remember, from the factored form, it's easy. We just set each factor equal to 0. So from the one factor, we get x equals negative 5. From the other factor, we add a 1 to both sides, we get x equals 1. So our x-intercepts are going to be negative 5, 0, and 1, 0. We have two of them in this one. Okay, now we're going to talk about how to switch from standard form to vertex form. We'll start with our given standard form. To find the vertex form, what we're going to do is we're going to group the x terms together with parentheses. Minus 5 is outside. If a is not 1, we have to divide out the a or factor it out. But since a is 1, there's no factoring out of a to be done. Because notice how the a is out front. Okay, in this case, there's nothing to factor out. So what we're going to do is we're going to complete the square. We need that coefficient of x squared to be 1 to do this. So we take the b value, which is a 4, we divide it in half, and we square it. So we're going to add a 4. So we have inside this parentheses with the x squared plus 4x, what do I have to add? I have to add a 4. Now, in order to keep the equal sign, we have to adjust for that 4. We could add a 4 to the left-hand side, but I could also just subtract a 4 back off. We're going to do it this way because I want everything to stay on the right and the y by itself on the left. So, okay, we are now going to write our perfect square trinomial as a binomial squared. Put together the -5 and the -4 to get a -9, and there's our vertex form. Now, I'm going to circle that up as my vertex form, but I want you to look at that. It's that x plus 2 is x minus -2, and that -9 is a plus -9. So my h is a -2. There's my y equals a x minus h, so h is -2 plus k. K is my -9. So that's our vertex is at -2, -9. That would be our turning point. Okay, the other thing we're going to make sure we put on this one is our axis of symmetry. That kind of got left off of our copies somehow. But that axis of symmetry is always going to be the vertical line through the vertex. It's going to be x equals a constant. It'll be the x equals whatever the h is. And that's the first page of our notes. Well, let's move on to the second page of our notes. All right. So on this one, maybe we should do this in 2 videos.